Okay, so 1.2, adding and subtracting fractions. So the goal here is to apply methods to convert mixed fractions to improper fractions and add and subtract fractions. Okay, so for all operations that involve we're going to call this rational numbers. Okay, so another way we can say a fraction is called a rational number. So right here, rational numbers. So these are called fractions. So you'll need to convert all the mixed fractions to improper fractions first. So back in elementary school, you're given all of these improper fractions where the numerator was bigger than the denominator. Okay, and you always converted them to something that looked like this. So a mixed number or a mixed fraction. So you have the whole number part. Then you had the fraction part here. Okay, this is good in elementary school, but in high school, we don't like to work with these kinds of numbers. We want to always work with improper fractions. So we're going to convert this mixed number back to an improper fraction. And if you forgot how to do that, it's very, very simple. Okay, all you have to do is take your whole number here, 2, multiply it with the denominator 5. Okay, so I'm going to write that here. So 2 times 5. And then you're going to add the numerator, 4. Okay, so plus 4. And everything will be over your denominator 5. So I'm going to write here 5. Okay. So 2 times 5, that's 10. And then I'm going to add 4, it's 14. So my answer here is 14 over 5. So here's my improper fraction. It's improper because the numerator is much bigger than the denominator. Okay. All right, so what about this one? What if it's negative? Okay, well, I'm going to just take the negative sign, I'm going to put it outside, and I'm going to write my fraction division line here, and I'm going to take my 1, and I'm going to multiply that with 3, so I'm going to write here 1 times 3, and then I'm going to add 2, so add the numerator 2, and write everything over the denominator 3, so over 3. All right, so it's very simple now. I just multiply 1 times 3, and I get 3, and I add 2. So let me just write here 3 plus 2 is 5 over 3, and don't forget your negative out sign in front, so it's going to be negative 5 over 3. If any of you have never seen this before, multiplication, instead of writing 1 times 3, I can write this as 1 in brackets and 3 in brackets. And in mathematics, we understand that to be multiplication between the two numbers. Okay. All right. And for any ELL learners who are a little bit confused when I talk about a fraction, so if I had to say 2 over 3, the top number is what I call the numerator, and the bottom number is what I call the denominator. Okay, just so we're not confused. All right, so moving on. So, however, one major difference with adding and subtracting rational numbers is we need a common denominator. Okay, one way to find a common denominator, which always works, is to multiply all denominators. All denominators. Okay, I left an extra blank space. The multiply should be written here. Okay, so however, we are really interested in finding the lowest common denominator. This is the LCD, lowest common denominator. So once we get a common denominator, we can add or subtract the numerators, but we leave the denominators alone. Again, all final answers should be in lowest terms. So let's look at example number 1. Adding and subtracting these two fractions. So 3 over 4 minus 2 over 5. Notice 4 and 5 are different denominators, so I have to find the common denominator. And again, the easiest way to do that is to multiply them. 4 times 5 is 20. So here I have 20. Here I'm going to write 20. I'm subtracting the two fractions. What do I put on top? Well, to go from 4 to 20, I have to multiply by 5. So whatever you do in the bottom, you do to the top. So 3 times 5 is 15. To go from 5 to 20, I have to multiply by 4. So whatever I do here, I have to multiply on the top. So 2 times 4 is 8. Now I have two fractions. I can subtract them because I have a common denominator. So all I have to do is subtract the top, the numerators. 15 minus 8 is equal to 7 over 20. Check to see if it's in lowest terms. Can I reduce to 7 anymore? No, this is as low as it can get. Okay, so 7 over 20 is my final answer for this one. Next one. Here's another two fractions, different denominators. I could multiply the denominators to get the common denominator, but I want you to also look at the lowest common denominator. And the way we can figure that out is by listing the multiples of 6 and 8. Okay, so listing the multiples means just skip count. So you have 6, 12, 18, 24, and 30, and I can keep going on. Okay, if I skip count by 8, I have 8, 16, 24. Whoop, oh, I'm going to stop there. The reason I'm going to stop there is because, look, I have found a common multiple, 24 and 24. That's the denominator I'm going to use. All right, so here I'm going to write each fraction as a fraction out of 24. Okay, so I have a minus sign here from that. Okay, and the plus minus will become a minus. Okay, opposite signs become a minus. Now, to go from 8 to 24, I multiply by 3. Okay, so 8 to 24 I multiply by 3. So I have to multiply the 7 by 3, and if I do that, I'll get 21. To go from 6 to 24, I multiply by 4. So I have to do the same thing on the top here. So 2 times 4 is 8. So I'm going to write 8. Now here are my fractions, 21 over 24, negative minus 8 over 24. And if I subtract these two, keep in mind your signs. Negative 21 minus 8 is negative 29. So you just subtract the numerators, but you keep the denominators. Okay, it's always good form to either write the negative on the numerator or just keep the negative on the side, but never write it in the denominator. Okay, so let's do part C, mixed numbers. So what I'd like you to do is convert these mixed numbers into improper fractions. Okay, so 2 times 5 is 10, plus 4 is 14, over 5, plus 1 times 3 is 3, plus the numerator is 5, is over 3, and there are my improper fractions. But these improper fractions don't have a common denominator. So what you have to do is find a common denominator. So again, find that lowest common multiple. So 3 and 5. What are the multiples of 3? Well, 3, 6, 9, 12, 15. And the common multiples of 5 are 5, 10, 15, 20. Oh, we found one here, 15 and 15. Okay, so I'm gonna use that. Okay, so 15. If I write this in terms of 15 and this one in terms of 15, what do I have to do? I have to multiply the 5. You have to multiply the 5 to get by 3 to get 15. So I'm going to multiply the 14 by 3. So 14 times 3 is 42. Okay, and if 3 times 5 gives me 15, then 5 times 5 is going to give me 25. And then I add these two together. Add the numerators only. 42 plus 25 is 67. Keep the denominator. Don't change that, so that's 15. Okay. Check to see if you can reduce it into lower terms, and I think you cannot. So 67 over 15 is my final answer. Moving on down here. So again, I'm going to go a little bit of a faster pace. You can pause the video if you need to just double check. Okay, so here, mixed number 4 and 2/3. So 4 times 3 is 12, times plus 2 is 14. So I'm going to write this as 14 over 3. The double negatives become a positive, so plus. And 3 times 2 is 6, plus 1 is 7 over 2. Okay, the common denominator here is going to be 6. So I'm going to write this as basically double the numbers here. So 28 over 6 plus, so 2 times 3 is 6, and then so 7 times 3 is 21. 21 over 6. And then if I add the two numerators, I get 49 over 6. Okay. Next one, mixed numbers again. Okay, so convert to improper fractions. So multiply 8 times 4, add the 1. So 8 times 4 is 32, plus 1 is 33. Write the denominator 4. And then 9 times 3 plus 1. So 9 times 3 is 27, plus 1 is 28 over 3. I have a minus sign in between. Whoops. Minus, okay. And then now I have two improper fractions. I have a different denominator for each, so I have to find the common denominator. And we're going to use 12 as our common denominator. So 12 and 12. Okay, so you can multiply 4 times 3 to get that common denominator. And so I have to multiply this 33 by 3, and that's going to give me 99. And I have to multiply the 28 by 4, okay, because 3 times 4 is 12, so 28 times 4 is 112. Subtract those two values. My final answer is going to be 99 times minus 112 is negative 13 over 12. Okay. Moving on to my next part here, example number 2, putting fractions in lowest terms, also known as reducing fractions. Okay, so 4 over 12. How do I do this without a calculator? Well, if you look at 4 over 12, if you divide by, it's like a little number sense. Here, if you divide by your numerator, 4, and you divide that the bottom by 4 as well, whatever you do in the top, you do in the bottom. 4 divided by 4 is 1, and 12 divided by 4 is 3. And when your numerator is 1, that's already considered a basic unit. You can't make it any smaller than that. So this is now in lowest terms. Okay. On your calculator, if you have a scientific calculator with a special button, the button would look like this. So here's this button, and it's going to look something like this: A with a B over C. This button here will automatically turn anything you write into a fraction, and it will put it in the lowest terms. Okay, so you can use that too. 22 over 36. Well, if I divide both by 2, I'm going to get 11 over 6, 18. Okay, and then 11 generally is an odd number. It's an odd number. 18 is an even number. Not much I can do here. I can't divide 11 anymore, so that's in lowest terms. 9 over 3 is just 9 divided by 3, which is 3, and 7 over 7 is 1. Okay, two of the same numbers cancel out. All right, example number 3. Mike, Billy, and Steven play on a hockey team during the year. Mike scored half of the team's goals, while Billy scored 1 over 8 of the team's goals. The team scored 128 in total. How many did Steven score, and what fraction does Steven's score represent? Okay, so a couple of ways you can do this. So one, remember, it's all about fractions here. Okay, and we're interested in the Steven's fraction, right? So Steven, so we're told what Mike scored, so 1 over half of them, and Billy scored 1/8 of them. So if I subtract Billy's fraction and Mike's fraction from the entire whole, I'll get Steven's fraction. Okay, so what's the whole? The whole thing is 128 goals, but I want to express that as a fraction. So the whole number, all of the goals can be represented by 1. 1. And then I can subtract, half the goals were Mike's goals, and then again subtract 1/8 of the goals, which were Billy's goals, and then whatever's left over would be Steven's number. Okay. So if you don't get this idea of 1, think of it this way. Okay, I'm going to just draw a circle. Here's a circle. See if I can move that circle a little bit. Right, let's move right here. Okay, right here. And then I'm going to divide this circle into 8 pieces. So the circle itself is considered one whole unit. But now, as I'm dividing the circle into 8 pieces, I can create these fractions. Okay? And so what's Mike? So Mike is half the circle. So I'm going to just shade in half the circle here. Okay, so this is Mike. And Billy scored 1/8. So I divided the circle into eighths. That's why I divide it into eighths, so I can show Billy's slice here. So I'm going to say Billy's slice here is this right here. So Billy. Maybe I should have used a different color, right? So let's see if I can still do that. Red. I use red. Okay, I'm going to fill it in with red. And there we go. Which means what's left? I have, whoops, I lost that one. So here's my red again. So save that. And let's try now filling in the rest with blue. So here's the rest. The blue covers how much? 3 slices of the 8. So 3/8. Okay. So we know the answer. Ooh, I lost my color again. So let's try that. So blue, just quickly shade it. All right, let's click on save. And so this is now Stevens. So just from a picture, we can get Stevens' answer right away. It's 3/8. Okay. But how do I show that? How do I show that using the math? Okay, so the whole circle is 1. I treat this as 1. Okay, what it really is just 8 slices out of 8. Okay. Mike is 4 slices out of the 8. So 1/2 can be. I can say 1/2 is the same thing as saying 4 out of 8. Find the common denominator, right? And then I subtract Billy's score. 1/8 of the scores are Billy's, and then I'm left with an expression here. Common denominator is 8, and I can just subtract the numerator. So 8 minus 4 minus 1, which is 3. And that's the same answer that I got here. Okay, so 3/8 of Stevens' score. That doesn't tell us how many goals. We can find out the number of goals by saying, well, if you have 128 goals, and I multiply by the fraction 3/8 of them, so 3/8 of my 128 goals is the number of goals for Steven. Well, then all I have to do here is just multiply 128 times 3, divide by 8. Okay, and that's going to give me 48 goals. So this is Steven's score. All right, so my last example. So we have here 8 friends bought 10 pizzas in total. 2 people at, or I should have said 8 5/8 pizza each, while the other 6 friends ate 1 1/4 each. How much pizza was left over? Ooh, okay, it's going to be interesting. Okay, so we have here 10 pizzas. 2 people ate 5/8 of the pizza, so minus 5/8, minus 5/8. Okay, well the other 6 friends ate 1/4, 1 1/4 each, so minus 1 1/4, minus 1 1/4, minus 1 1/4. How many times do we do this? Well, it's 6 friends, so 6 times. 1 1/4, 1 1/4, and 1 1/4, or 1 and 1 over 4. Okay. All right, so let's try and simplify all this. I'm going to start off with 10, subtract. What about this? So minus 5 and minus 5 make minus 10 over 8. And here we have, well, how many ones do we have? 1, 2, 3, 4, 5, 6. How many quarters do we have? 1/4, 2/4, 3/4, 4/4 make another whole number, 7. And then I have another quarter and another quarter together. When I add these two, make a half. So I'm going to subtract 7 and another half. Okay, or if you don't see the half, I'll say 2 out of 4, 2 over 4, 2 quarters. Okay. Now, a bunch of different fractions here. We're going to find a common one. I'm going to use 8 as my common denominator. So 10 can be written as 80 over 8, right? 80 divided by 8 is 10. And then I have minus 10 over 8. And what about this one? How do I convert this? So 7 times 4 is 28, plus 2 is 30. My denominator is 4. But I'm going to change that improper fraction into one that I can use. So here I'm going to say 80 over 8 minus 10 over 8 minus, let's see, double this up. So 60 over 8. Okay, multiply the top and bottom by 2. And if I subtract everything here, 80 minus 10 minus 60 gives me 10 over 8. So basically, you can say there's 10 over 8 pizzas left, or 1 and a quarter pizza left. Okay, so again, converting an improper fraction back to a mixed number.